So let's talk about a very important command that we have, which is the find. Okay, the find. So in the find, you could search any matrix or any vector with a criteria. So with a criteria. So let's presume that we have a naval academy that is recruiting students for it, and there's a condition that the height must be 66 inches or higher. So I already was playing with it. So let's say the height. First of all, we gotta start with in here, control copy. Let me go in here, my file here. So okay, we start with the clear CLC and the clear, and then I created a vector which has 7 heights for 7 applicants. All right. So if I would like to know who meet the criteria, I could use the find command. So let me say accept equals, all right, and find. I could use find, and then inside the find I could have the criteria. So for the height, okay, height, and the height has to be greater than or equal 66. All right. So let me run this. Of course, will ask me to save. So let me save it. So let me call it, program 1, whatever. Let's call it P1. All right. And you see, the accept people is number 2 and 4 and 5 and 6 and 7 and 6 and here. Let me go in here. I'm sorry. So let me run it in here. All right. So it's like 2 and 4 and 5 and 6 and 7. Why 2? So 2 is higher than 66 inches, and 63 and 65 are less than 66, right? Then we have number 4, 1, 2, 3, 4, 7, 2 is okay. 5 is okay because it's higher than 66. And 6 is okay, and 7 is okay. So it will give you the index of the people. If I would like to know who those are rejected, very simple. I could write. Let me write it with you. So for example, declined people that declined. So we could say decline. Who we gonna decline equals. So find. Right, find, and we're gonna decline anyone with height less than 66, right? And that's it. So we have the decline, okay, which is number 1, and number 3 will be declined. All right. Of course, we could write it in a nicer way to display the who are the people that we need to display. So we could, for example, say, all right, and here we're going here. So we could display it in a display, the command display or display a text. So we gotta open a quote in here, and we're gonna say the following candidates meet the height requirement. Let's say requirement. All right. Okay. And let me put semicolon here, and then I have to print out. Okay, if printf, which we have learned before. Again, we're gonna have a text, okay, in here, and we're gonna write that candidate number, whatever the number. I gotta have a placeholder for that number for 4 places, 0 decimal points, and it will be float. and then I have an is, and I have a placeholder for the height. So again, it's 4 places, 0 decimal points, and it will be a float. All right, inches tall, and I gotta put /n. Okay, so what are we gonna get? So comma in here. So what I gotta get the data from? What I gotta get the data from? I gotta get it from accept. All right, and the height of accept. All right, so let's run it right now. Here you go. Let me bring this up like this. So these are the indices for the accepted. These are the indices for the decline, and then I could write it in a very nice format. So candidate number 2 is 67 inches tall, and he is accepted, and so on and so forth. So I put everything together. All right. All right. And I could do the same thing for the rejected. I could do the same if print for the rejected. All right. Well, I mean, we're trying to find from a vector. So what if we are trying to find from a matrix which has multiple rows and multiple columns. All right, so for example, let's say that there's 3 conditions. Two conditions actually. So the condition, let's say the condition. So let's create another file, or let's work on this one. Okay, let's work on this one. So we have the applicants. Okay, the first thing it will tell you that the height has to be 66 inches or more, and the age has to be 18 years old to 35 years old. So this is for the first applicant, this is the second applicant, this is the third applicant, fourth applicant, fifth, sixth applicant. All right, so let me comment this like this for now. Comment it. So I need to find the applicants that meet the criteria. That's all I need to do. Let me comment this too for now. Okay. All right. So let's run this one. Let's run it. Okay. Here you go. So these are the applicants. The first one, 63 years old and 18. Of course, he will not be accepted because his height is less than 66. His height is less than 66. The second one, it will be accepted. His height is above 66 inches, and his age over 18, and so on and so forth. Right? So now, if I would like to find who passed the criteria, I could find, and I have 3 conditions. The first condition is the applicant, and then I choose all the rows. The column one, this is the column one which has the height, it has to be greater or equal to 66. As simple as that. And then you have in here and, the logical and. So we have to have 3 conditions met. The applicants, and I'm checking now the column 2, and the age has to be equals or greater than 18 years old. And the third condition is the applicants less than 35 years old. All right, so let me run this. Here you go. Who meet this criteria is number 2 and number 4 and number 6. That's the only people meet the criteria. That's the only people meet the criteria. The age criterion, and the height criterion. And of course, I could, put the results in a nicer format. So in here, like, I put them in one table. So the results. So I have the pass, which is coming from here, and the applicants pass 1 and applicant pass 2. Let's run it in here. So 2. Okay, as you see in here, I created like a matrix. The matrix it has the pass, which is the people who passed. Okay, then we have the applicant, the applicants, which is like applicants. which we look at the column 1, and the applicant, which is column 2. And then I did the transpose. Actually, I could remove the transpose to show you. So that's what it is. So 2, the height and the age, 4, the height and age, 6, the height and age. When I transpose it, like put in here, let's run it again. Now it will look, reversed, like reversed. Okay. Now I could use the printf statement like I used it before. So I'm saying applicant, okay, number. Then in here I have the index number, and this is his height in inches, and this is his age, and I'm getting everything from where? From the results. So it will print this first and this second and third in here from the results, right? The results, and that will be out. Let's run it. All right, here you go. Applicant 2 is 67 inches tall and 19 years old. He's good. Applicant 4, number 4, is 72 inches tall and 20 years old. That's good. Applicant 6 actually is 78 inches, which is higher than 66, and 34 years, which is higher than 18 or less than 35, the condition, and that will give you the result. All right. Furthermore, if we need to, okay, now in here when we do find in this application the find, it will return the order. Okay, how the order is done. How the order is done. Okay, it will give you the row number. It will give you the row number, right? But if let's go in here in the temperature, take a look on here. So let's say that we have we'd like to know the row number and the column number for the element in the matrix. As you know, if it's a vector, we have one row, multiple columns. All right, but if we have a matrix, we could have multiple rows and multiple columns. All right, so let's take example in here. These are temperature. All right, temperatures. So these are measurement for temperatures. All right, in multiple stations. So the column represent the number of the station. So let me highlight. Let me comment this for now, and let me comment this for now. All right, comment this for now. Yes, now it's commented. So let's run this. All right, so in here what do I have? I have the first row, which is 95 and the 100 and 98, and the second one is 97 and whatever, 99 and then 98, and so on and so forth. So the column represents the number of the stations where the temperature was taken, So in here, if I'm looking for a certain temperature, let's say I'm looking for a temperature that is higher than 98.6. So let's run this. Here you go. So it told me element 3, element 4, element 5, element 6, element 8. All right, how these are counted? They'll count. This is element 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9. So it goes through the first column, then the second column, then the third column. All right. So now you have 9 elements. You could view it by your eyes, but if you have like a matrix which has like a million number, you will not be able to view it by your eyes. So you need to know the column and the row numbers, and that's very easy. You could just save the column number and the row number, so like this. So in here, let me comment this. I don't need to see it now. And in here, let me run this. So here you go. So in here it tells me, okay, the first element, row 3 and column 1. Where is row 3? So this is row 3 and column 1, then it's this value. The second one is row 1 and column 2. This is row 1 and column 2. Third one is row 2 and column 2. So this is row 2 and column 2, and so on and so forth. So you could always save the row and the column number of the number you are looking for, right? So it's a very simple, very easy to do. There is other two commands, which is all and any. So all, it will tell you, it's a logical function that it tells you if all, and this, by the way, the results for true, any and true, it will be what? True or false? True or false. And in here, the same thing, it will be true or false. So the result will be what? Okay, this will be 1, 0 for false, or 1 for true. Same thing in here, 0 or 1 for true. This is or, actually. Alright, so so for example, if I take, for example, this one, let me take here, okay, and let me copy it. Copy. Did I do anything? Undo. Is there undo in here? What did I do? I have no idea. What did I do? Okay. So I'm sure there is here. Undo here. I did in here. Okay. So let me copy this. Control C, copying. Alright. So let me replace the find with all. So the question in here is, are all the elements in the temp 1 greater than 98.6? The answer is no. So when I run it, will give me 0. Okay, it gave me for temp 1. So it looked at the column by column, right? So column by column. So it looks at the column 1. Okay, let me just comment this. Run it again. Okay. So in here, so it takes a look. First column, are all the elements in here higher than 98.6? This is no, then it's false. 1 is enough to be false. How about this? All of them gave you 1. How about this column? Some of them are not. Alright, some of them are not. So okay. If I use any, that means it's enough to have here anyone, anyone, okay, equals, for example, any. Alright, and then let me copy it. That's the easiest way to do it. Control copy, and in here. So okay, it's any of the columns has at least one value higher than 98.6. Let's run it. Yes, all of them have at least one. Alright, so this is like a shortcut for it, and I hope it was like useful. So find, all, and any are very useful for matrices and vectors. You should practice it very well, and it's combined with the criteria written by logical and operational tests.